If you come from middleware or you're curious about how attenuations can be used to change the way that sound plays in Unreal Engine, I have been in your shoes and I was there today.
Why, God, why?
I thought what I would do is take you through 4 different ways to use attenuations in Unreal. This is native Unreal, so we're going to be covering a couple of different shapes using cones, spheres, boxes, using reverse attenuation so that as you walk up to an object, you stop hearing it, and using occlusion as part of your attenuation as well, so that as we go inside geometry, you stop hearing elements. Now, the final project, we're just going to have 4 sounds. I have this really fun scene with a beautiful little watchtower, one of the Epic Games free downloads from the Fab Marketplace, probably a couple months ago now. It's worth kind of grabbing them whenever they do appear, just because they are so very valuable to have.
Okay.
This watchtower, it's quite simple. It's a 4-tiered system. So we have the top box right at the top here, where we want a kind of eerie wind playing just inside. And for that, we're using a box volume instead of a sphere emitter, which is a little bit strange if you're used to just kind of placing everything in spheres or cones. Specifically, if you come from other middleware, that might be the way that you look to approach it. There are a few different attenuation shapes. Outside of this watchtower, you have this staircase where I'd like to place some sort of creepy wind haunt you as you're going up. We don't know what's up there, and we're trying to communicate that, but I don't want that to be playing when I'm down on the ground. For that, I'm going to be using a cone emitter so that I kind of project up part of this staircase and get this idea that the staircase is rattling only in certain parts, or it's just howling just perfectly through a single spot. The next component is this small little emitter here for some birds. When birds are in trees, they like to sing, and when people come close to them, they tend not to. So I want to be able to walk up to this and have them actually get quieter. Then finally, I have a quad. The quad itself doesn't really matter where it is. It's not spatialized, and you might be used to thinking of attenuation being all about spatialization when it doesn't actually have to be about spatialization. What it can be about is the construction of a single asset that sits, and in this instance, it's a quad that sits over the whole map and doesn't actually shift at all, but has occlusion so that when I go inside this volume, and even around the back corners of this, it might happen a little bit just with the occlusion. When I go inside that volume, I don't need to do a whole exclusion thing and develop all this wonky logic. What I can do instead is just say, now that it's occluded, play less. You can see when you open up the attenuation, you're probably used to seeing that, at least that very first one checked almost 1,000% of the time, because you think, well, it's an attenuation. That's what attenuation should be, right? Right. But in this instance, we're not interested in placing it in the world, and I don't want it to get quieter as you move away from it. I don't want it to be spatialized. I don't want it to be affected by the air absorption. I don't want it to be affected by, I do want it to be affected by reverb, but not by focus or anything else. I just want this occlusion. That's to say that I want to cast against physics bodies and filter out or low pass the result when we hit one. That way, we're going to get this interpolation time. That's going to cast into an object and say it's hit. That's not going to work for us, so start bringing that low pass down. That way we don't get the bed when we're inside, but we also don't have to make lots of volumes around things. So that's the quad. The quad just does occlusion. That way we start playing the sound. It's even play on activate, and as I walk around, I'm going to have some visualization on here, just so it's really nice and obvious. You can see my quad here. Quad's this nice, healthy green line. And it doesn't change volumes as we walk around or as we get close to it. That's because it isn't spatialized and it's not attenuated that way. Now we can see our birds, and their birds might be a little bit subtle. We can kind of hear them in the background. They are mixed in with a few other branches and leaves and things like that. But as we walk up, you'll see the color change. And now that we're underneath the birds, they're actually not going to be heard. This is to sort of emulate the idea that as we walk up to objects in the world, birds and wildlife don't like people. Some might make sounds with people, or you could have a person shouting out, "Hey," or something, or some kind of alarm. or thing that might need to happen, and then as we walk up to it, it actually switches off. The attenuation for that one has a custom attenuation curve. Custom attenuation curves are really powerful in that they allow you to dictate how the range should actually work in terms of the mediation of the volume. In this instance, I have 0 to 1 being the 100% of the radius, or 0 to 100% of the radius, and the sphere is the shape that I'm going for there, with the inner radius of about 1,000 with a fall-off distance. Some of these numbers might even get a little bit tricky, and if you're just opening Unreal or you're starting a new project and you're not seeing, this nice attenuation that shows me where things are and what's actually going on there, all you need to do is go into your whichever patch you'd like to hear and just make sure this enable attenuation debug is on. That will allow you to see some of these shapes as you're adjusting them. This means here, when I adjust the attenuation shape, if I make the radius larger or smaller, I'm changing the amount of space that's required, or I'm changing the detection radius really for the birds to hear and see players. And then the fall off distance is going to be a smoother version of that. So there's going to be sort of a slew as we start walking in, and then as we walk in, we're going to be entirely attenuated and we're not going to hear any birds, which I think is a really cool effect. Our next object is this trigger volume that drives this really cool looking cone attenuator. I chose a cone attenuation here just to have something a little bit different, but also because I didn't want really static sounds. I didn't want something that played the entire way up. For instance, as you walk onto the start of this, why would it be making sound? Why would it be howling away? We're not quite high enough for the wind to really pick up, even though we are on quite a large hill. So maybe we are high enough. Instead, what I wanted is something kind of asymmetrical. So as you walk up part of the staircase, you're going to hear it. I'll give you a demo of what that sounds like. So we're going to run over here. Okay, and you're going to see birds are chirping away. That's fine. We're happy with that. And we're going to see our trigger volume has turned on our howling effect. And now, even though we're quite close, the attenuation is definitely big enough for us to hear this here. We still don't hear it because we're not within the cone shape. And instead, we're going to get it all of a sudden here. Now, you might want to make that a little bit more open. You can see we're already gone because we're really just part of that cone volume. If you could imagine drawing traces across this screen, even when I pan the camera out here, you can see it changing color, right? Changing volume. But it's nice. We get this asymmetrical, fun variant here where we hear just in the shape of the cone. Now, how do we do that? Well, that's thankfully not even as complex as the bird's volume. However, it is a little bit hard to get your head around some of these cone angles and radiuses, or radii. The main element to change here is the attenuation shape from a box or a sphere to a cone. And we can then play with our cone radius. It's going to be the projection length. And you'll see two parts of the cone here. You'll see like an inner radius and an outer radius. That's that fall off radius that all of attenuation shapes have. We have a cone angle for how focused we want it to be. In that instance, that playthrough, I actually feel like it maybe needed to be a little bit less focused just to catch it on the way up. It does mean that we could potentially hear it when we're up in the box though, so you might need to tweak that a little bit more. We have the fall-off angle for that weakness. We have an offset just to shift it around a little bit, and the fall-off distance to be how much we want that to affect it. So I could even make that a little bit smaller as well. There is a sphere radius if you always want, say you have a buzzing light, or you have some aspect or some element that the source makes sound and then it projects off, a faucet or a fire hydrant, something like that, where you might want the stream of water to be part of the attenuation set, and then you also want the sphere radius to be right at the bottom. In my instance, I don't really need this sound source here, but it's a handy one to have just for the play. And then the cone sphere fall off distance, I didn't really use any of these. I do have some air absorption in this one, which I think is fun because the distance that I am from the object, I want it to really change if I'm at one end of the cone or the other end of the cone, even if the volume is the same. For that, especially if you learned high cut, low cut, you'll need to flip that around, that understanding around, and think about low pass and high pass, and think about the low pass frequency minimum is what the low pass is going to be when you are as close to it as possible, when there's as minimum attenuation as possible, and the cutoff frequency max being when you're at the max attenuation, when you're at the most amount of attenuation. So this will be the most filtered, that being if I'm at the edge of the cone, at the moment it's like up here, I'd be way down at 3500 hertz for the low pass frequency. Then from there, we're going to have the high pass, which is the same. And I tend to like to band pass this. Physics is a little bit more complicated than just a blanket band pass. And maybe at some point, you could go and write custom curves for each of these to really, really shape it, especially if you had something that was a very important set piece. I'd probably encourage you to look into writing a custom curve for your absorption. That gives you full control over how the frequency changes, especially if you're thinking of classic example, like helicopter coming or approaching. You kind of get that mid-frequency boost and the low cut at a distance and comes closer, and part of the charm of all of this work. But there I have some reverb and I have no occlusion on that. Finally, the last element of this system is this unsettling interior where I literally just have a box. I just did this because a lot of people don't use a box at all, and you actually can use just a base box shape, which is this box shape here. Again, you'll see it has extents for XYZ dimensions, being the length, width, and height. That's the word I'm thinking of. Length, width, and height of the box. And we have the fall off distance as well, just to smooth that out. You don't necessarily need a fall off distance. If you have an open door or something, that's going to change it again, but it's going to move through that. Anyway, these are 4 different ways that you can use attenuation. You can use this in all of your projects with no code support at all, which is really, really nice, even if you like breaking it out, because code gets really complicated, and when you need to build a new system, you're going to have new bugs. So have a play with changing your birds into reactive environments that really listen to where the player is, as opposed to just always having birds. It does mean that you could play things at the cliffs and not elsewhere, or not at the cliffs but elsewhere. And it leaves you some opportunities to have some fun ambience elements. Now, as I walk up the tower, I'm going to get up to my trigger volume, which should start playing at some point when I get close to wherever the trigger is. There it is. And we hear our wind howling away, and as I pivot away from it, kind of gets shut off pretty quickly. I think this is, you can see our occlusion here. This is our occlusion hitting our attenuation really, really, really hard. Might want to smooth that out a little bit as well. But occlusion is another handy way to do attenuation. However, it is one of the more expensive ways to do attenuation, so be careful when you're using it. And we're going to start hearing our unsettling interior. As we take another step back outside again, over the next couple of seconds we can hear that quad come back. And now we have a pretty fun environment with just 4 sounds. This is the system that you might need to learn a little bit more about attenuation, be able to have the sounds in the world play the way that you expect them to play, which could be a little bit difficult really before you start breaking them down and looking through documentation and working out how attenuation actually works, especially if you're used to coming from sphere land and only sphere land. There's actually some better shapes and some more creative ways that you can use attenuation that actually solve some implementation problems as well. So check it out, share what you make, and I'll see you next time.